section 3.7. Inverse functions. Ready? When we started functions, we looked at 3 sets of bubbles. So here is one set. Here's another. And here's another. This is what we had a long time ago when we looked at functions. What did we say about the first bubble? Set of bubbles. They're Venn diagrams. I should not say bubbles, but what did we say about this? This is a function, and furthermore, it's a one-to-one function. Why? Because if I want to go backwards, I can also create a function. Agreed? So this is a function that is one-to-one. This one, there is no discussion here. This is not a function. It's a relation. Very good. And what about this one? Not one-to-one. So we're not interested in these two situations at this present moment, because only one-to-one functions have what? Inverse what? Functions. They all have inverses, but we're interested in the one-to-one functions because they have inverse functions. So that's our first note. Only one-to-one functions have inverses that are also functions. So in short, we like to say only one-to-one functions have inverses. But all of them have inverses, but not necessarily functions. Okay. How do I determine an inverse function, and what really happens here? Okay, so let's say I have a function f that is one-to-one. And let's say I have 2 corresponding to 4 and 3 corresponding to -2. It is one-to-one. I can create the inverse function. Notation, f raised to -1. Do not ever read it like that, though. So this is f inverse. It does not mean 1/f. This is just a simple notation that says f, this notation, f inverse of x, is the inverse function of f. So that would be f inverse. Here's my question for you. If function f has the point 2, 4 and 3, -2, so these are for function f, can anyone dictate what happens? What are the ordered pairs for function f inverse? Of course, 4 becomes the x for f inverse, and y becomes the y. So this will be 4, 2, and this will be -2, 3. So this is a mathematical way of writing the domain and range. So if a function is defined, so this is domain, and this is the range, we say f is defined on set A, taking values in B. Can anyone tell us what happens to f inverse? Where is f inverse defined and where it takes its values? Of course, indeed. It's the exact opposite. Perfect. Now, I'm looking for the end of chapter right here. How do we find, what is the procedure? It's a 4-step procedure to find the f inverse. So I'm going to give you a function, x plus 1 over x minus 3. Of course, x does not equal 3. And I'm going to tell you it's 1 to 1. We will graph these functions in the next chapter. I'm telling you for now it's 1 to 1. And I'm asking you, do you think this function will have an inverse function? Of course. So it has f inverse as a result of being 1 to 1. And let's say we're asked to find f inverse. It's a 4-step procedure to find a function that reverses what f does. That's what it means. Undoes what f does. Okay, step number 1, replace f of x with y. Am I allowed to do that? If they are the same, I'm allowed to do it. If they're not the same, I'm not. Are they the same? Sure. Of course. So y equals x plus 1 over x minus 3. In step 2, and now you tell me if this is allowed. Interchange or swap x and y. In other words, x equals y plus 1 over y minus 3. But the question is, am I allowed to do that? Am I allowed to replace x with y and y with x? And before you answer, look at what you already told me. You said 4 becomes x for f inverse, negative 2 becomes the x for f inverse, and this 2 becomes the y for f inverse, and this number 3 becomes the y for f inverse. So am I, in my search for the inverse function, am I allowed to swap those two? Only then when I'm trying to find the f inverse, of course. Very good. In the next step, step 3, I will solve for, what do you think? For y. I want to solve for y because I'm looking for f inverse, and now the f inverse becomes y. Very good. So, okay. What type of equation is it? How do I solve it? It is a Of course, it has x in the denominator or y in the denominator. That's what I'm looking for, rational function. Furthermore, it's called a very good. What do we do in a proportion? Thank you. So x quantity y minus 3 equals y plus 1. xy minus 3x equals y plus 1. Remember, we are after y. Okay, next step, please. xy minus y equals 3x plus 1. I'm solving for y.
We'll take y common.
Thank you. Final step, replace y with the notation. What are we looking for? No, we're not looking for f of x. F of x was given. We are looking for
Inverse.
Indeed. So f inverse equals 3x plus 1 over x minus 1. Of course, x not equal 1. Let's look at another problem, this time from your book. I made that one up. So let's choose a problem. then I would like to answer a couple of questions from here and the sketch of the graph of F inverse. Okay, so any preference? I do have a preference, either 13 or 14. 14, very good. X minus 6 squared. Any questions about this procedure? Let's review the procedure one more time. Whenever I'm told that function is one-to-one, I know it will have an F inverse. First step, I replace f of x with y because they mean the same thing. Second step, I interchange x and y, and I'm only allowed to do that when I find the f inverse, otherwise I won't. Then I'm solving for y. So all these steps, and I solve for y. And finally, this is the inverse function of the original function. And I use the notation for this. I replace y by f inverse, and that's it. So we want to look at another example, and then we'll talk about why something interesting that happens. I'll tell you in a minute. So let's look at 14. And this is on page 264. And we are given f of x equals x minus 6 to the second power. We use transformations. We know exactly this graph is x squared, shifted where? To the right 6. This is the graph. Is this a one-to-one function? Okay, perfect. So I have three functions for you. The first one is quadratic. By the horizontal line test, not one-to-one. So if I cut the graph with a horizontal line and I find two or more corresponding x values, I will say that this is a function, but it's not one-to-one. For y equals, let's say 2, or let's say better 4, I get negative 2 and positive 2. So this is not one-to-one. This is a cubic function. It could be fifth degree function. However, it's not one-to-one because for a particular y value, this time I even find 3 x values. We know what this function is. It's a square root. By the horizontal line test, so not one-to-one. By the horizontal line test, let's say for y equals 4, I only get one value as x equals 2. So this is one-to-one. So you perfectly identify that this is a quadratic function, and it is not one-to-one. We can quickly graph this function. We know it's shifted to the right at 6, 5, 6. So here's the graph. So here we are asked to find its inverse. So the first thing we have to do is what we call truncate the domain of this function. Is this function one-to-one everywhere on its domain? No. But let's imagine that I do this. And I attach to this function the domain x greater than or equal to 6. So I don't want the function to be defined everywhere because it's not one-to-one. I want the function to be one-to-one, and I selected the right-hand side of 6. Is this function one-to-one now? Yes, it is. So now I can determine the domain, which you already have, and please give me the range. Very good. We have not determined the inverse function, but you can already give me the domain of the inverse function we know nothing about, but you can already give me the domain and range. They're both carved in stone. What is the domain of this function? Okay, hold on. Okay, let's go back. So let's go back. If the function is defined on A taking values in B, then the inverse function must be defined on one more time. If the function is defined on A, taking values in B, then the inverse function is defined on B, taking values. Okay, so coming back, one more time, we carved in stone the domain of function f. It's carved in stone the range of function f. Now I need the domain of f inverse carved in stone, although we know nothing about the inverse. Very good. And the range of f inverse? It must be. Otherwise, it's not going to be the inverse function. Right? Is that clear, everyone? Good. So now let's find it. Let's find it. Good. Step 1. I replace. Good. In step 2. No, not yet. Swap x and y. So in step 2, I have x equals y minus 6, everything squared. In step 3, square root, very good. I'm solving for x. I'm solving for y, so I'm going to copy it here. Good. So I have y minus 6 equals. No. Thank you. Thank you. So then y equals 6 plus or minus the square root of x. Here's my note to myself. No way. There must be only one. Also note to myself, which one? The one that fits the condition that we established way before we even determined it. So please tell me which one. Indeed. So in step 4, I chose 6 plus the square root of x. Why? To be the f inverse, because f inverse is defined on 0 to infinity, and the answer has to be 6 and above. If I make the error to select the other one, that's going to be 6 and below. So I would say, no, only 6 plus the square root of x. I would have not had an idea, I would have to go back and further investigate if I hadn't determined from the very beginning the domain and range. And now obviously it's very clear. I can't choose the other one because 6 minus the square root of x, if I put x to be 0, it's 6. But if I put x to be 25, 6 minus 5 will be 1, and 1 is not in the range. If I put 81, I'll have the square root of 81, which is 9. 6 minus 9 will be negative 3, and negative 3 is not in the range.
So you have to put it in the range of the domain.
I'm determining the inverse function of this. So I have to stick with what the conditions are given here. I can't choose something that is not the inverse function. Yes, Brian?
So if we were wanting to make it like a one-more function and it's not, would it have to be like midway?
No. Absolutely not. You can say, I want to create it from 10 to infinity. Or you can say, I want to create it from negative infinity to 0. As long as you choose a piece of it that is 1 to 1. Yeah. You can create a new function based on what you chosen initially. Very good question. Now I would like to graph both on the same coordinate system. So graph f of x, which is x minus 6 squared, for 6 to infinity, and f prime of x, not f prime, I'm doing derivatives with another class, and now in my head everything is prime. Sorry about that. Of course, it's the inverse. Okay, which is 6 plus the square root of x, of course, from 0 to infinity. We already have the graph of f of x. 1, 2, 3, 4, 5, 6. Here's the graph of x minus 6 squared. Now, can anyone graph 6 plus the square root of x using transformations for us? Square root of x. Up 6. So here's the square root of x. Up 6. 1, 2, 3, 4, 5, 6. I did not plan correctly because I wanted to show you, and I'm going to graph it one more time because I need to show you something very interesting and very important. One, 2, 3, 4, 5, 6. And that's the x minus 6 squared. And then so this is 6 plus the square root of x. And we're going to write a note. Which function is this? Yes. The graphs of f of x and its inverse, f inverse of x, are WRT with respect to the line help. The graphs of f and f inverse okay, are what? Are, what word am I missing here? Yes. Symmetric with respect to the line? For any inverse functions, their graphs will always be symmetric with respect to y equals x. Always. Last thing I want to say about this topic is the following. Please give me two very simple inverse functions. I'll give you one, and I would like you to create the inverse function of multiplication by 3. What do you think the inverse function of multiplication by 3 will be? Very good, of course. I claim that they are, inverses of each other. That's my claim. And you should say, prove it. And I will prove it. In the previous sections, we talked about f comp g. And we talked about g comp f. And before we go any further, I'm going to say this. I choose one of you to give $3 to. 5 minutes later, I say, give me my $3 back. What happened? No deal, right? I give you $3 and I take it back. So addition by 3 to your pocket and subtraction by 3 from your pocket did not change the money that you have in your pocket, correct? Okay. So then this is a function composition. if I apply them, either I give you 3 and then take it back, or I take 3 from you and then give it back to you, it doesn't matter, the order doesn't matter, what would happen? The answer will always be if they are inverses of each other. Now, if I give you 5 and I take 3, those are not inverses of each other. Addition by 5 and subtraction by 3 are not inverses of each other. But if I give you 3 and take 3 back, or I take 3 from you and give it back to you, no deal. So if two functions are inverses of each other, the function composition will give us what? Always. Plain x. Plain x. So this happens only if they are inverses of each other. And this is called the property of inverse functions. The property of inverse functions. If two functions are inverses of each other, the function composition must be plain x, not x squared, not x over 3, not 5x, not x plus 1. Plain, simple x and nothing else. So now we are trying to prove that these two are inverses of each other. So let's find f comma g, which is f of g of x, as we know, which is f of 1/3 x, which is 3 times 1/3 x, which equals plain x. The other one, g comma f, is the same thing. Is g of f of x, which is g of 3x, which is 1/3 times 3x, which is x. That is the reason why these two functions are inverses of each other. Because the function composition, either way, is the same. Equal to x. Okay, so let's look at an example. You choose either 17 or 18, in which we are asked to use the property of inverse functions. For the following exercise, you use a graphing, use function composition to verify that f and g are inverse functions, inverses of each other. Either 17 or 18. Just for you to see another example. Which one? 17, perfect. So in 17, on page 264, we have f of x, which is the cube root of x minus 1, and g of x, which is x cubed plus 1. We are asked to show whether these two functions are inverses of each other or not. So I have to find f comma g, which is f of g of x, which is f of x cubed plus 1. See, this is what we studied a long time ago. Being able to read a function, identify what the pattern is telling us, and being able to evaluate. In this case, we have to evaluate function f of x for the cube for x cubed plus 1. So can anyone dictate the cube root of, so this x becomes now x cubed plus 1, and then minus 1. So we have the cube root of x cubed, and we know that this answer is, of course. Do you think that the other one will be x? Of course. Do we have to show it? Unfortunately, we do. But can you already conclude that f and g must be inverses of each other? Yes. Okay, perfect. So let's find g comma f, which is g of f of x, which is g of the cube root of x minus 1. Now be careful because we have to look at g. G says blah cubed plus 1. But now blah is all this. And then plus 1. So the cube root of x minus 1, everything cubed and plus 1. And we know what the cube root of the cube root of something cubed would be. And that would be x minus 1 plus 1, which is indeed x. And now we can conclude f and g must be For sure, they are inverses of each other. Now, can anyone give us F inverse? You can say I need a 4-step procedure. No, you don't. So how much is F inverse?
G of x.
Of course. Of course, thank you very much. So that is x cubed plus 1. Absolutely. And if I ask you what is G inverse, what will you say? Of course. Awesome. The cube root of x minus 1. They must be inverses of each other, so one is the inverse of the other. Very good. Okay, I know I have like 9 minutes left, 10 minutes left, so I like to look at these tables. So for the following exercises, evaluate or solve, assuming, yes, any questions for me, please? Assuming that the function f is 1 to 1. So let's take a look. And then I'd like to look at something from that table. So for the following exercise, evaluate or solve. So we are given some information, and then I'd like to look at one example with a table. So we figure out how to use that. Any preference? Okay, then thank you for the your vote of confidence. I will choose. Thank you very much. Okay, 36 on page 265. I know it's a lot. So let me also say this. I know it's a lot in this class. I know you have to be so patient for almost 2 hours. I know that. I know it's difficult. So I just want you to know that I'm aware of it. Okay, so we have f inverse of -2 is -1. We are asked to find f of -1. Of course. Of course, let's look at the what I call bubbles. Here it is. F inverse applied to -2 is -1. So this is for f inverse. Now what will the function do? The function will be applied to -1 and they must return -2 because they are inverses of each other. Very good. Perfect. Okay, so now let's take a look at this table. And I would like to solve this equation in 40. So this is 40 on page 265. And it says f inverse of x equals 7. For the following exercises, use the values listed in table 6 to evaluate or solve. So I'm assuming this is table 6. Yes, it is. So we're asked to find f inverse of x that is 7. So f inverse, so these are the values of x and these are the values of the function. So we want f inverse of a particular value here to be 7. So f of some value to be 7. F inverse of some value to be 7. Right? So f inverse will be applied to the y values, right? So f inverse of 3 will be 7. Do we agree with that? Okay. So then f inverse of 3 is 7. Okay, any questions? Okay, one last problem, and I promise to stop after that. 45. To convert from x degrees Celsius to y degrees Fahrenheit, we use the formula f of x. So this is problem 45 on page 266. This is just a real-life application of what we are looking at. I'm sorry? Oh, yes, of course. Thank you. Thank you. Sorry. Okay. So 45 on page 266, we're given f of x equals 9/5 x plus 32. Find the inverse function, if it exists, and explain its meaning. First of all, what type of, yes, I forgot. We have to give my colleague 5 minutes. So can you give me 1 more minute to finish this? Come in, okay, have a seat, come in. I completely forgot that. Okay, so first of all, I'd like to identify the type of function. What type of function is this?
Linear.
Of course, perfect. So is this function 1-to-1? Imagine the graph. Yes. Cut it with a horizontal. Okay, perfect. So it means that it's 1-to-1. Will it have an inverse function? F inverse exists. So first step, please, towards finding the F inverse, please. First step.
Replace f of x with y.
Perfect. So y equals 9/5 x plus 32. Step 2, please. Very good. X equals 9/5 y plus 32. Step 3. So for y, what would you recommend first? Yes. I would recommend cleaning it up. If you don't want to multiply both sides by 5, that's fine too, but I recommend that. 5x equals 9y plus 160. And then we have 5x minus 160 equals 9y, and finally y equals 5/9 x minus 160 over 9. Finally, this is F inverse, which is 5/9 x, minus 160 over 9. Any questions? No, we are not taking square roots or anything. No, no, no. And it cannot be, remember? It cannot be, otherwise the function is not 1-to-1. There must be only one.